Hello everyone, I hope you're doing well. So in this video, we're going to discuss the solutions for Codeforces Educational Round 135, which was rated for Division 2. So let us start with the first question. The first question says that we have been given some balls and there are some in different colors of balls and the total count is odd. Like if you sum all the balls of different colors, then the total sum would be odd and there are n different colors, right? Now in each step, what you do is you just pick one of the two balls, right, of different colors. Like you can pick this first one and you can pick this second one because they are of different colors. Let me just write it down first. So if one is here, this is the ball of the first color, this is the ball of the second color, this is the ball of the third color. In one step, what you can do is you can just pick any two of them which are different in color and take them out of the bags. So after one step, this will be left like this, right? So we have to tell the ID of the ball. This is the ID, or you can also say the index of the ball, which will be left at the end, right? Because at the end, at some point, there will be all balls of the same color only. Like even if it was like this, right? So if you take these two, this will always be left because even if there are two balls, they are of the same color and we cannot take them. So we have to tell the index of such balls, right? So if you carefully observe, then the answer can always be the index of the maximum element. This will always be the answer, right? So what you can do is in the code, what I've done is, let me just write it down. So I've taken a vector of size n and I take input in that vector, right? So I initialize the max, which is the maximum element that I have got till now at v of 0, and I initialize the result as 0. So I traverse through the vector, and if v of I is greater than the maximum, then I set the maximum as v of I and the result as I, or the ith index, and at the end I just print result plus 1 for 1 based indexing. So this is how the solution of the first question works. So we just have to take the maximum element and print its index. This will be the final solution, right? Moving on to the second question, which is best permutation. So like this question says that we have been given a permutation, we want to form a permutation of length n. Now there are certain conditions. We will traverse from p1 to pn, and if x, which is initially equal to 0, if x is less than p1, then add p1 to x, otherwise set x as 0. So basically we have been given a permutation, we have to form a permutation. For example, if there are 4 elements, the permutation should be like p1, p2, p3 and p4. So this should be the permutation, right? Now x is initially 0. Now if in at we have to traverse I from 0 to n minus 1, or from 1 to n, whichever you take, you can take it as you wish, right? So in each step, what we have to do is, if x is less than pi, then what we can do is x is equals to x plus pi. In any other case, if x is greater than or equal to pi, then we have to do x is equals to 0, right? So after traversing from 1 to 4, there will be a certain value of x, and we want to maximize this value of x and print such a permutation which maximizes this value of x. So a very careful observation would be, for example, there are 7 elements for n is equals to 7. The maximum answer that is possible is equals to n plus n minus 1. This is the maximum value of x. I'll show you how. For example, if these elements were at the last, right? So before 6, even if I take the smallest element, that is 1, right? If I add 1 and 6, then it will be equal to 7. And when x reaches here, when x is equals to 7, then x will become 0 in this in the last step, right? So I don't want to do this. So I cannot take any element before 6, and when x reaches 6, it should be equal to 0, so that when x here is 0 and 0 will be less than 6, so x will become 6, and at this step x will be equal to 6, then x will become 6 plus 7. So this will always be the best case. The best case or the best answer would always be n plus n minus 1. So our question reduces to that we have n minus 2 elements, right? And we have to form a permutation with these n minus 2 elements such that the value of x is always 0, right? So this is our final question or our reduced question. We have derived this particular conclusion that we want to form a permutation with n minus 2 elements such that the x is always equals to 0 at the end using those conditions mentioned in the question. So if you observe that if x is even, right, so n minus 2 will also be even. For example, if n is even, then n minus 2 will also be even. So let us assume that n is 6. So we have to form a permutation of 4 elements such that x is 0. So we can always take it as we can always write it in decreasing order 4 3 2 1. So what will happen is x here is 0 at the first step. Here it will become 4, and then again 4 will be greater than 3, it will become 0. Then it will become 2, then 2 is greater than 1, it will become 0. So at the end of 4 elements, the value of x would be 0. So if n is even and n or n minus 2 is even, then the answer would be like this. So let us discuss some other cases. Like for example, n is odd. So in this particular case, there will be actually three sub cases. We'll discuss it. These were the three cases that I found: if n mod 3 equals to 0, if n mod 3 equals to 1, and if n mod 3, oh sorry, uh, this is after, let me just write it. This should be n minus 2. This should be also n minus 2, because we were discussing about n minus 2 elements, right? So if the n minus 2 elements, if it is 0, right, n mod 3 is 0. So if you want to arrange them, you will see that we can write all of them in increasing order like this, right? Because what if there are n, if n minus 2 mod 3 equals to 0, we can always write them in increasing order, because n, for any n, it will be always less than n minus 1 plus n minus 2, right? So this is our claim, and this will always be true for all numbers in this particular case, right? It will always be less than equal to. If you take the smallest number 3, for which n minus 1 and n minus 2 exists, the sum will be 3. 2 plus 1 is 3. And for any other numbers, the sum would always be greater than n. For example, if we take these two, 3 plus 2 is 5 and this number is 4. So it will always be, n will always be less than equal to n minus 1 and n minus 2. So if there are, if n minus 2 mod 3 equals to 0, then we can always pair them in a group of 3 like this. Right, so these two elements would form a sum greater than or equal to 3. So right here it will be 0. When we sum these two elements, it will always form a sum greater than or equal to the third element. So again, at this position it will become 0. So at the end we will have 0. So this was the discussion of case 1, right? So this is the case 1. So let us take the second case where n minus 2 mod 3 equals to 1. So let us take an example of where n minus 2 is equals to 7. So this is our case. We have to arrange the first 7 elements: 3, 4, 5, 6, 7. We have to arrange these 7 elements such that at the end x is equal to 0. So what we can do is we can leave the last 3 elements as it is, and if you carefully observe, then the remaining elements will always be even. If you separate the last 3 elements, then the remaining elements will always be even. So if they are even, what we can do is we can write them in the reverse order, as I've already explained. Or you can also do just swap the adjacent elements. This would also work, right? Either you can write whole of it in reverse order like this, or you can just swap the adjacent elements. Both of them would work, because at the end both of them would be 0 at this point, right? X would be 0 at this point in both of the cases. So these are the two cases you can form, and after it, these are 3 numbers, and as we have already discussed, for 3 numbers, the like x is always 0, because for every multiple of 3, x is always 0 at the end, because 5 plus 6 would always be greater than or equal to 7. So this is how you can deal with case number 2, right? And the third and the final case is when n minus 2 mod 3 equals to 2. So for this case, let us assume that n minus 2 mod, it should have been n minus 2 mod 3. Yeah. So it is n minus 2 mod 3 is equals to mod 3 is equals to 2. So we can take an example of 5 here, where n minus 2 is equals to 5, right? So if we have these elements, what we can do is we can leave these particular elements as it is, and we can reverse these elements. So this will always be a multiple of 3, right? This will always be a multiple of 3. So if we write it as this, the sum of these two will always be greater than or equal to this, right? So at the end, when we partition here, at the end x will be equal to 0. And now if we reverse them 5 and 4, then what will happen? This will be greater than this always. So at the end, again x will be equal to 0. So this is how we have discussed all the cases. This was the case 3. So like there might obviously be some other formations in which you can solve, but these are some cases that you need to consider, and these cases can also be solved with some other examples, but this is what I have taken in the code. So as you can see, what I have done is, if n is even, I just print all of the elements, and first of all in reverse order, and print the last two elements in the normal order, right? So if n minus 2 mod 3 equals to 0, so what I do is I just print all the elements in increasing order. And n minus 2 mod 3 equals to 2, what I do is I just print all the elements. I just for n minus 2, I just remove the last two elements from n minus 2, print all the elements, and then print n minus 2 and n minus 3 again in reverse order, because n minus 2 will be greater, and then the last two elements, right? And for when in other condition, when n minus 2 mod 3 is equals to 1, what I can do is as you can see, I told you about two cases here, right? So I just, in the code, I have implemented this particular part where I swap adjacent elements and at the end print three elements together. So if you can see, I have taken a loop from 2 to less than n minus 4. I just write the second element first and the first element later, and then print all the remaining elements like this. So there might have been a better way, like to print it using a for loop, but this is also the same. Whichever you find convenient, you can use that method. So again, I'm telling, like, these are the cases that you need to consider, but to solve these cases, there might be other formations also, but this is one of the valid formations that you can use, right? So moving on to the third and the last question for today's video. So this video says that we have been given two arrays A and B, and we define f of x as the length of the base 10 representation of x without leaving zeros. So for example, if there is a number 1, 2, 3, then f of this number n is equals to 3, right? And if we do f of 3, then it will be equal to 1, right? So we have been given two arrays, and what we can do is we can change any value ai to f of ai, and change any value bi to f of bi in one step, right? And we have to make a and b equal to each other. And in what way they are equal? If all the elements present in a are equal to all the elements present in b, means if I say that A has 3 and 4 and B has 4 and 3, then this is, both of these are equal, because if we sort them, then they will become equal like this, right? So they should be equal in this particular manner. So we have to find the minimum number of steps such that both of the arrays are equal, and the value of ai and bi is always less than 10 raised to the power 9. So if you carefully observe, then 10 raised to the power 9 has 10 digits, and 10 raised to the power 9 plus 1. So this is the limit of ai and bi. Ai is always less than equal to this particular number. So the number of digits would be 9. So you can always make all of them equal in you can always make any number ai equal to 1 in just 2 steps. How? Because if the number ai is 10 raised to the power 9 minus 1, then the number of digits would be 9, right? And if we again calculate the number of digits in 9, then it will be equal to 1. So in 2 steps, at maximum 2 steps, we can make all of them, we can make a particular number equal to 1, right? So this is the first observation. Now what we can do is, we can, first of all, what I have done is, if there are two arrays a and b, so there must be some numbers that are common in both of them, right? So we can first of all remove those numbers and then work on the remaining elements. So for example, I have removed common elements. So the first step is to remove common elements. Remove common. So I have removed all the common elements in A and B. Now A and B vectors have nothing in common. So what I do is, if any element of A is greater than 9, right? Because if I have removed the common elements and if any element is greater than 9, then it cannot be possible because every element should lie in the range 1 to 9. Right, because I cannot increase any number. If I, for example, if I have 8 and 1000, right? So if this is array A and this is array B, I cannot increase this to this. I cannot increase 8 to 1000, but I can certainly decrease this particular number, right? So what I do is, if any element in A or B is greater than 9, I increase the count. What I'll do is, if AI is greater than 9, I increase the count and replace AI with f of AI. F of AI. So f of n is defined above in the question, and I'm using the same definition. So I'll also do the same for the vector b. If b of I is greater than 9, I'll increment the count and set b of I as f of b of I. So this is how we proceed. So now in the final vector, what we have is all the elements will be from 1 to 9. Right. So again, I can sort it and I can remove all the common elements. So if I have one here, I have one here, I can remove it. I don't have to worry about this. I don't, if I want 9 is here, 9 is here, I can remove it. I don't have to worry about them. Right. So at the end, I will be left with numbers which are in the range 1 to 9 in both of the vectors, and they are different in the sense they are at different indexes. So there might be a case like this. For example, if I have 2 and 3 and I have 3 and 4 here. So there might be a case like this, but they are not equal yet. What I have done is I have removed only these elements. So for example, if it was like this, I have removed these two elements, I have removed these two elements. But since 3 is common in both of them, but I have still not removed them because AI is not equal to BI in sorted manner. Right? If they both are sorted, then AI is not equal to BI. So I still need to do some work in it. Right? So I remove all the excessive elements and I am left with 2, 3, 3, 4. So this is just a sample test case. For example, I am left with 2, 3, 3 and 4. These are the numbers I am left with. Right. And the maximum, so I have some integer count. I have removed these elements because they were same. I have some integer count. So the minimum answer now can be count and the maximum answer can be count plus the remaining elements, that is 2. So 2 into 2. So this can be the maximum answer from now, right? Why I have taken 2 into 2? Because there are 2 elements here, and if I apply one operation to each of these and one operation to each of these, then all the elements will be reduced to 1 1, right? So at the end, the maximum answer can be count plus 2 into 2. Right. So our task is now, because count is fixed, our task is to reduce this particular number. So let's see how we can reduce this number. So for example, if I have 1 here, right, and I have somewhere and I have 3 here, right. So this is just an example that if I have a pair of 1 and 3, then I can take this particular number and reduce it to 1. Right. So then this way both of them will be equal. So 1 is acting as a very important pivot in this particular case. Whenever I have 1 and I have a number which is not present elsewhere in the array, right? So what I'll do is I'll change this number to 1. So in this case, let us take it to be t. So for example, this was t earlier. If I have 1 left and any amount of 1 left, and if I have 3 extra here, then the number of steps would be reduced by 1. T minus is equal to the number of extra steps will be reduced by 1, because I can change this particular to 1 in 1 step. Right. Earlier I would have taken 2 steps, because if it was like this, then I would have taken 2 steps. But since one of them is already 1, then I can change 3 to 1 in 1 step, and 1 step will be saved. So this is one particular case, very important, right? What happens if I have this particular array? So if I have something like this, so what if I have a 3 here and a 3 here, right? So I can take the minimum of both of them, right? So minimum of both of them is 1, so they will always be equal to each other. So in this case I don't have to change anything. For example, if it was 2 or 3, I would have to change both of the numbers, but since both of them are equal, then I don't have to change anything. Then I will do t minus is equals to 2, right? Because they both of them are already same, so these two I eliminate, and I do t minus is equals to 2. And for all the remaining cases like these 2 and 4, I don't need to do anything because they were already included in t in the first place, and at the end I just print count plus t. So this would be my final answer. So I have tried my best to reduce this value t by checking if there are extra ones, then I can reduce t by 1. If both the elements are same, then I can reduce t by 2. So this is all I can do. And how do I check for all the elements? I just run a loop from 1 to 9. Right? I can, or 2 to 9, I can check one separately and run a loop from 2 to 9, because this is the only range so the numbers will be presented. Right. So let me just show you the code, then it will be more clear. I have taken two vectors a and b of size n and taken input in both of them. So I take a variable count which is initialized with 0, and I take two maps in which I store all the elements of a and b. So the purpose of these maps is to remove all the common elements first, right? So I traverse in the first map which stores the elements of vector a. Now I initialize these two variables with value. Value is the current element and count is the number of elements with the value equals to this particular value, right? So I assign both of them and I find the same value in the second map. If it is found, then I find the minimum of them and reduce it from both of them. So at the end, after running this loop, I just clear both of the vectors a and b, and for all the remaining values in x6 the first map, and for all the remaining values in yy, I just push them in a and b respectively. So I just now traverse from in both of the vectors a and b, and what I do is I traverse from 0 to a dot size, because the size would now be changed. And if so, here is a way to check the length of the here's the way to check the length of the AI. I first convert it into string and just find x dot size. So this is a convenient way to check the length of the number. So what I do is I first convert it into string. If a of I is greater than a of 9, then what I do is I set a of I as x dot size and increment count. Similarly, for bi, I set string y is equals to string of, I convert b of I into string, and if b of I is greater than 9, what I do is set b of I is equals to y dot size and plus plus count. So now I sort both of the vectors a and b and create two separate vectors of size 10 and 0 initialized at all the positions. So I now create a variable t, which was the second part. So I fix the value of count and I calculate the value of t. So again, if ai is not equal to bi, for all ai equals to bi, when they are equal, I don't consider that case. If they are not equal, I just add 2 to t, because this would be the maximum thing I will have to do. And I increment xa, which is the first vector, with a of I, and xb of b of I. So all these values will lie in the range 0 to 9, and this actually it will be from 1 to 9, and it will tell me how many elements are there with value 1. So now what I do is, if there are some ones, I just subtract them. If there are some ones, I take minimum of both of them and subtract it from both of the vectors. So what I do in this case, that if there are some ones, I just remove them, and what I do is I subtract it from the t vector as well. So the number of ones that are left after this operation would be stored in maximum of x of a comma x of b, right? So these are the number of ones left. Now I traverse from 2 to 10 and I take the current element as minimum of both of them, right? What is stored in current? That is minimum of both of them, because these will be the number of elements which are in common. For example, if I have 2, 2, and 2, 2, 2. So minimum of them would be 2, right? So these two things, these two parts would be removed, and the total decrement in t would be t minus is equals to 2 times 2, because there are present to, this is the length 2, right? And each, if I remove each pair, then it will cause a decrement of 2 individually. So I subtract twice of current, and I do x of a minus is equals to current and x of b minus is equals to current, subtracting both of the values from both of them. So now I create a new variable which is named as tt. Now this will store the left amount. So for example, in this case, this 2 was left. So now I will check whether there is any 1 to associate with this 2. If there is any 1 to associate with this 2, how do I check this? I create a variable use, and which is the minimum of tt and left one. So this will be the number of ones that I can use to pair with this extras, with this extra 2, right? And then I can subtract left one from use. So I can subtract use from left one and use from t as well, because if I, for example, if there was 2 here and I have 2 ones, so I will take this one and pair it with this 2, and I will take this one and pair it with this 2. So what will happen is this 2 will get reduced to 1 and this 2 will get reduced to 1 in 2 steps. So that is what I have exactly done. I have subtracted I have subtracted use from t, and I have also subtracted the number of ones left, because use will be the number of ones used. So let me write it here also. So use is the number of ones used in this step, right? And at the end I just print count plus t. So this would be my final answer, and I've because count will always be fixed and t is the value I'm trying to minimize, such that the value of count plus t is minimum. So this was the solution of problem C for today's contest. I hope you guys were able to understand the solutions. So till the next video drops, keep coding, stay safe, bye bye.